Stellar scale engineering. The concept of stellar engineering refers to the deliberate orchestration of artificial changes to a star or other similar astronomical object for the purposes of engineering a useful construction, power source, or some other function. It's similar to planetary engineering, that is, engineering of planets. But of course, we're talking about stars. In 1964, the Soviet astronomer Nikolai Kardashev proposed a scale for measuring the output of interstellar civilizations in the cosmos that can be used for long-distance communications. This has come to be known as the Kardashev scale, and three types of civilizations were defined. A Type 1 civilization has the capacity to store all of the energy which reaches a home planet from its parent star. For the Earth, this is of order 10 to the power 17 watts, when the reality is that today our power consumption for the present civilization is around 10 to the power 12 watts, or equivalent to an energy consumption of 10 to the power of 19 erg per second, where 1 erg is equal to 10 to the power of minus 7 joules of energy. A Type 2 civilization has the capacity to harness the total energy of its parent star. The total output power of the Sun is around 10 to the power of 26 watts, or equivalent to 10 to the power of 33 erg per second. The proposed way by which this can be achieved is through a device known as a Dyson-Stapleton sphere, and we'll discuss that a bit more later. A Type 3 civilization has the capacity to control energy on the scale of the entire galaxy. The total power output of the Milky Way, for example, defined as its luminosity, is around 10 to the power 37 watts, or equivalent to an energy consumption of around 10 to the power 44 erg per second. Further work by the American astronomer Carl Sagan in 1973 proposed a method of extrapolating and interpolating intermediate values on the assumption that there was a Type 0 civilization that would control around 1 megawatt of power. Using this scale, it is possible to show that human civilization on Earth has an average power consumption of around 10 to the power of 12 watts, as mentioned earlier, which means we have a Kardashev value of around 0.72. Many other versions of the Kardashev scale have now been proposed, but they all largely agree we are far from the masters of our own local energy sources as such a young species. The ability to engineer astrophysical sources such as stars is an interesting idea which could equally expect a more advanced civilization to have attempted. So let's briefly discuss some of the structures that could be engineered in the future by those advanced extraterrestrial species, or indeed by a future human being. Dyson-Stapleton spheres. These objects were first suggested by the British philosopher Olive Stapleton in his 1937 novel Star Maker. The idea was later picked up and refined as a thought experiment by the physicist Freeman Dyson in 1960, who reasoned that such a structure would be a result of the escalating energy needs of a technological civilization. Such a sphere, or a set of orbiting structures, would completely encompass a star and capture all or the majority of its power output. It would be uniquely distinguished by an infrared emission spectrum, which would make such structures detectable to long-distance observations. One has to ask, however, whether such an advanced civilization with escalating energy needs would instead choose to occupy other star systems by interstellar diffusion, rather than huddling around the light of one lone object. More credible versions of the idea, known as Dyson swarm, consists of many large number of independent constructions orbiting in a dense formation around a star. Another variant is a ring world, a hypothetical orbiting structure around a star, but rather than a complete sphere, it is instead a ring. The idea was popularized in the 1970 science fiction novel by Larry Niven. Matryoshka brains. This is another type of hypothetical that is really an extension of the Dyson-Stapleton sphere, but instead of power output purely through energy conversion, the output is used to derive massive computational capacity. The idea was conceived by Robert Bradbury, and the concept takes its name from the Russian Matryoshka dolls, since the analogy is adopted so that there are the equivalent of nested spheres within each other, each built around a star, and drawing all of its power output. The inner shell would have the temperature of the outer shell atmosphere, and the outer shell would be so cool as to be equivalent to the temperature of space. In theory, such a large computing architecture could be full artificial intelligence, or could create artificially simulated universes for people to exist in. The Matryoshka brane concept looks even more complicated than the Dyson-Stapleton sphere. Shardov thruster. This is a term used to describe a type of megastructure which is able to use a star's radiation output to create usable energy, such as for the purpose of producing thrust and therefore actually accelerating the star through interstellar space and any object orbiting it, in any direction. 3 variants of classes of stellar engines have been proposed. It involves the use of a large mirror or light cell to balance gravitational attraction and radiation pressure outwards from the star, such that the net pressure of the star will be asymmetrical and the excess radiation in one direction would act as net thrust to move the star from its original position. Any planetary system that is in orbit around the star would also be dragged through space, and so the entire stellar system could in principle be moved. All of the above megastructures are different types of stellar engines that could in theory be constructed by advanced extraterrestrial civilizations, or by a future human being. This presents interesting observational opportunities in looking for either live stellar engines or dead stellar engines, the remnants of a once forgotten civilization. This seems possible in a universe which is 13.8 billion years old. There has been several postulated sightings of potential stellar engines by the Kepler Space Telescope. This includes the object KIC 8462852 and EPIC 204278916. But the analysis is so far inconclusive. The former, also known as Tabby's star, is an F-type main sequence star located in the Cygnus constellation at a distance of around 1,276 light-years. Astronomical studies of changes in the star's brightness could not be attributed to intrinsic variability, and one of the hypotheses being proposed to explain the unusual blocking of the light emission is indeed a stellar engine. We do not yet know whether advanced extraterrestrial civilizations exist, let alone have built large megastructures in space, but certainly observational programs that seek structures out or eliminate their possibility will add to our knowledge of life in the universe. It would seem that in our pursuit of inquiry as to the various manifestations of existence, our most powerful tool is that of the imagination, which enables us to see alternate futures that may or may not exist, and therefore help to direct our research programs. Indeed, this may be the most important service that the literature of science fiction has ever given us as its legacy.